Alright guys, so I know you guys were playing around with exponential functions in class, and you were playing the game that required you to change the equation and make sure that all the balls hit the stars. So you don't really know anything formal about these types of equations yet, or these functions, but you've at least seen what they look like. And so what we're going to do now is we're going to kind of put it into perspective with the other types of functions that we've talked about by listing the domain, range, and end behavior of these four functions. So what we have to do first is classify each of them, because just by looking at the equation, it's pretty easy to tell what type of equation they are, because there are some features that you'll notice immediately, like A. A just is f of x, which is 3x plus 2. And we all know that since this is an x to the first power, and it's the only x in this equation, that this is linear. B says g of x equals negative 2x squared. There's your hint. If 2 is the highest power of x, then this is a quadratic. H of x's highest power is 3. It's a 4x cubed, so it's a cubic. And then D has j of x, and that's a little different than what we've done in the past. We've got negative 3, and that's the base, but it's to the x power. So since the variable is now in the exponent, we have an exponential function. So that is going to look like the functions that you were playing around with in class. So what we're going to do now is we're going to state the domain, range, and end behavior of these four functions. And it's going to be pretty easy for some of them. Sorry, and we're going to have to really dive into plugging in extreme values to see what's happening with some of these functions. All right, we're going to start off with our linear function. That's going to be the easiest one for us to deal with. So I want to state the domain, I want to state the range, and we're also going to describe the end behavior of this function as well. So remember, the domain is talking about all the possible x values that I could put into this function. If I could put any x value in here and I would get a result, then my domain is going to be every single number, and we'll just call that all real numbers. But if I'm limited in any way, then I have to express how I'm limited. What numbers can I put in? So the way we know this is there are a couple different things we can do. We can play around with this graph, and we can just go forever, and we can see, will it ever stop in either direction? And you'll see that as we go to the right, it's never going to stop. And as we go to the left, it will never stop, because it's just a line, just like the types of functions you've been dealing with in Algebra 1 forever. You know that it never ends. Usually that's why we put arrows on the ends of them, to show that it's just going to continue in those directions forever. So I can prove that there's no limit here. Well, I guess this wouldn't necessarily prove it, but it would be giving you a pretty good idea. I could put in f of 15 or 12,589, and I still get a number. And these numbers just keep getting larger and larger. If I put in a larger number, I'm just going to get even a larger result. I could put in any negative number I want, and I'd get a very negative result. So with a line, the domain here is going to be all real numbers, and so is the range, because I'm not limited in any way in either direction. Remember, range is up and down, domain is left to right, and range is the numbers we get out of it. Domain is the numbers we put into it. Okay, so now let's talk about end behavior. As x approaches infinity, we're going to make a statement there, and we're going to make a statement here. Well, as our function goes this way, forever and ever, it goes up. And as our function goes this way, forever and ever, it goes down. That's because it's a line, so it just goes in those two directions forever. So as we approach infinity, y is going to approach infinity. But as we approach negative infinity, y is going to approach negative infinity. So we've got our domain, we've got our range, we've got our end behavior. So now we're going to do the same thing for our quadratic. All right, there it is. Now we know that quadratic functions go forever in these two directions, but obviously it's not going to go forever in the positive y direction because it stops and turns around. So that's going to be reflected in our range, and it's going to be reflected in our end behavior. We'll say that our domain, because our domain is talking about all real numbers, right? There's no number that I could not put into this function. I would always be able to put something in here for x and get a result. So that's not a problem. But there are some results that I couldn't get. Like, there's no number that I could put into this function that would give me a result of 5, because 5 is not in the range of this function. It doesn't go up that high. It stops right here and turns back around. So where is the limit? Well, let's find it. I'll look at my function. Where does it stop? It looks like it goes only as high as 2.125. So we'll say that the range is from negative infinity to 2.125. And I'll put a bracket there because that 2.125 point is included in this range. Infinity is not really, it's not a value, so I have to put in open parentheses because I can never reach this, but I've reached 2.125. You can see it, it's right here. So we use a bracket to denote that end of our range. All right, so we've got to talk about end behavior now. What's going on with this function to the right? What's going on with this function to the left? Well, as x approaches infinity, it looks like our function goes downwards. And as x approaches negative infinity, it looks like the same thing is happening. All right, so let's talk about our cubic function. Okay, we've got h of x. It's here in Desmos. I could test it by plugging numbers in, but I can see it here as well. So let's talk about the domain. The domain of this function, is it limited in either this direction or this direction? We know that it's not because it's a cubic function, and we've dealt with this before, so its range is going to be all real numbers, or its domain, sorry. And its range is going to be just like linear functions. It's going to move in the positive y direction. Ooh, don't mean to do that. In the positive y direction and the negative y direction forever and ever. And if I zoom out, I can see that that function is going down and up forever. So the range is also all real numbers. It's not limited there either. But let's talk about end behavior. Which one will end behavior be most similar to? Well, I'll put it right here. So as x approaches infinity, what's happening to this function? Well, it looks like as we go this way, the function's going up. So as x approaches infinity, so does y. And as x approaches negative infinity, y is approaching negative infinity. It's going downward, right? As we go this way forever, the function is going to go downwards forever. It's just like our linear function. So our range is all real numbers, our domain is all real numbers, and we've got our end behavior. Now let's talk about our exponential function, because this is a very new type of function to us. All right, the domain of this function is a little tricky. It looks like it very clearly goes this direction forever, right? It's just going to go that way forever and ever and ever. But it seems like it does not go that way forever. It looks like it's going to hit a wall and drop off. That's kind of the interesting thing about these functions, is that it actually does go that direction forever and ever and ever. And the only way for me to really prove that to you right now is just to show you that I could put j of some giant number in here and I would get a result. Like, it doesn't look like it ever hits 20, right? But I would be able to evaluate this function for 20. If I put in 20, I get a result. It's a really, really, really negative number, because this function does actually go everywhere in both directions, but it is a really steep function as it heads negative. So it's going to reach 20, but at a crazy negative number. And you could see that I could put in 100, and I still have just a very negative number. It will actually be going this direction forever. So our domain is actually still all real numbers, and our range is where we get limited. In the negative x direction, it does not always go up. So a better way of saying that would be, if I travel this way forever, it does go this direction in the x direction forever, but it's not going to reach every y value because it is going to reach a level that it cannot go past. And that level is actually 4. I could put in j of some really negative number, like negative 500, and there it is. That's as high as it's going to go, right? And I could put in 562 still. I could put in 1,000 still. So that's where we're limited there. So the range, it will go in the negative y direction forever. So I can still say negative infinity, but it will stop at 4, and it will be the top of our range. So the last thing we have to talk about is end behavior. The end behavior of this function is pretty easy to see once you have your domain and range sitting there, but as x approaches infinity, we talked about how there is no limit to the domain, but it's moving downwards as we do that, right? So as we go this direction, it goes downwards. So as x approaches negative infinity, or x approaches infinity rather, y approaches negative infinity, and as x approaches negative infinity, well, as we go this way, y doesn't actually approach infinity. It does move up, but as we said, it approaches 4 forever, right? It's getting closer and closer to 4 forever and ever and ever. It's not actually going to reach infinity or even approach infinity. It's approaching 4. So that's your end behavior for that exponential function. So I really just want you to see that with these exponential functions, this is pretty important here. Your end behavior is very similar as when we talk about one of your directions. It will approach positive infinity or negative infinity in one of your directions, left or right, but in the other direction, it's going to approach a number, some value, because an exponential function is really going to taper off there, or it's going to start tapered off and then explode upward. Your domain will be all real numbers, but the range will be very different than the types of ranges we're used to dealing with. So this is just kind of to get you used to exponential functions. We're going to play around with domain and range in class too. I apologize for this being a really long video. I did not intend it to be this long, but remember, all you got to do is watch it and take the notes along with it. So I'll see you guys in class tomorrow.